here. So, as you guys know that we've got a YouTube channel called Introduction to Statistics, right? 180. We also have an Instagram page which is NSPC Academics. So from now on, every session that we do will be live on these two streams, either on Instagram or on our YouTube channel. So please do subscribe here and also follow us on Instagram. Right? Who doesn't have it? Oh, nice. Oh, guys, I'm looking at the months. Right. Okay. Wait a minute. Police. Wow. Okay. Let's say Anzwang Mutunangak. Ne? Khona bangazwanga awukwazi ukuhleba wena mfundisi. Okay? But let's say we don't know this. Okay? Then someone asks you, let's say if you describe the well-known celebrity, right? Then someone asks you, what can you say? 17. You say Fundiswa is 17. When other ones 19. Yeah. Right? When 19. When 3. Okay. Take one last case. Sister, also sister. Now we do. Okay. Then comes me. Oh, okay. Before I say, I guess, how old is she? Let's then you're being asked to write a story based on her, right? Meaning, you were to write an article about her. You're a journalist of some sort, right? Then you say your mentor is Fundiswa. Right? Fundiswa. Right? Your mentor is Fundiswa, and her age is 17. Right? Mind you, you don't know her age, right? You're guessing her age. And you say it's 17, some say it's 19, some say it's 20. So this is the first paper. You wrote this, right? You're the journalist of your own paper, then you write this, right? But I also have a paper, but on my paper, write the same thing. Same thing. My mentor, okay. My mentor, let's put my mentor here. It's your nice picture here. Then you say my mentor is Fundiswa and her age is 17, right? And you've got me. My mentor is Fundiswa and her age is between 17 and 19. Which paper would you buy? This paper, your paper, or my paper? If you're choosing this one, why this one? If you're choosing that one, why that one? Remember, so Abili Asia's age, which is this age, right? So which paper would you buy? Which one? This one. Why this one? This one got a single statistic, right? Which is a single statistic of your age. This age, this is so this is a guess, right? So this guess might be true, might not be true, right? But it's only a single statistic. But this one contains two statistics. So Fundiso's age, it's either 18, 17, or 19, right? So there are more than one guesses here, right? But this one only contains one guess, right? Then the question comes. So can you see the importance of an interval? The importance of an interval is the fact that an interval contains more than one statistic, right? Remember, what is a statistic? A statistic is something that is calculated based on the sample, right? So this interval contains more than one statistic, right? And within these statistics, there might be a true value, right? I mean, in this case, there's no true value, right? But there might be a true value other than using just one statistic and concluding with it. So it's better to use the interval. Okay? Now, the next question comes into play. How sure are you that within this interval you're giving us, there is a correct parameter? Now we've got this question. Now, before we go into details with this, can you guys borrow me something to write? No, afraid to. No. So now I've just taught you the importance of an interval, right? So now let's talk of something based on reality, right? In daily life, we've got what is known as the population, right? And what is a population? A population is everything of the same character, right? And from the population, we've got the sample. What is the sample? A sample is the subset of the population, right? So out of this population, we've got things which are referred as parameters, right? We've got things which are called parameters. Parameters is everything calculated based on the population. True, right? So what are those parameters? You've got your mu, which is average, right? You've got your p, which is proportion, right? You've got your variance, right? All these are referred as parameters, right? Then what else do you have? You've got your sample, right? The sample, you've got estimates, right? What are estimates? These are statistic estimates that estimate these parameters, right? What are those? You've got your X bar. Your X bar, what does X bar estimate? The sample mean. The sample mean estimates the average from the population, right? Right? You've got your P head. Your P head estimates the proportion from the population, right? Your then you've got your variance, right? Which is denoted like this. It's calculated based on the sample. What does it estimate? It estimates the variance of the population, right? So every statistic estimates the parameter, right? Mind you, these parameters are always unknown most of the time, right? Why? Because it's difficult to get information based on the whole population, right? Right? Okay. So if they are unknown, but you want information based on these, the best way to find these is to estimate them using relevant statistic, uh, these statistic, right? Okay. Are you guys still with me? Sure. You've got these guys. These guys estimate this because most of the time these are unknown because they're from the population, right? Like for instance, if you wanted to understand whether do people understand stats 130, I mean the first year stats in the whole of South Africa, would you go to each and every one who's doing stats 130? Or I mean, guys that do the first year statistics, you wouldn't go to each and every one, right? Because it's difficult, right? What can you do then? You'll take the sample, right? From the sample, you'll want you'll ask these individuals whether they pass state 180 or they fail. From that, you can deduce the average of people that pass state 130, right? Then, but but your conclusion will not be based on this sample, but the whole population, right? Because what you're interested on is information based on the whole population, right? Mercedes wouldn't have built or made an A45 if only a few people liked it. Their aim was the fact that everybody will buy the car, right? But for them to make the car, they needed a few people to approve of it. Then from those few people, they deduce that most people will like the car, right? So every decision that is made from the sample, the conclusion is for the population. Okay, which is why then it is important that everything calculated based on the sample, which is a statistic, must be close to this one, right? Because at the end of the day, the conclusion you'll make based on these things you calculated based on the sample will be for the population. So this must be close to this. Now, how do you see that something you've calculated based on the sample is close to this? By the standard error, right? That's how the standard error come into place. Error. Obviously, there's going to be an error. Can you see that? There's going to be an error if you're estimating something that you don't know with a statistic, right? Like for example, your age. You said you're 23, right? But people that say they don't know your age. Some will say you're 17. So this is unknown. Let's take this as the parameter. So this is unknown. So from this, let's take this as a statistic, right? So So some people say 17, 19, some said 20, right? So can you see that there's an error, right? So you've got 23, which is the actual average. You've got people saying 17. You've got other people saying 19, other people saying 20. Let me write this: 17, 19, 20. But the actual one is 23. Then you also have other people maybe saying 24, right? Can you see that there's an error between the actual average, right? So, with that being said, if you don't have long tables, thank you. So, with that being said, okay, so every time you've got or you've estimated your statistic, you've got your statistic, you need to include error for you to be as close as possible to the actual parameter, right? Okay, so that's why you need to say x bar plus or minus your error, right? Because if you include your error, that means the close you're going to be to the actual parameter. Because your interest is your parameter at the end of the day, right? Okay, so what is your x bar? Let's take someone who said your age was 23, right? I mean, who said your age was 17, right? So you've got 17 plus or minus. What is the error between 17 and 23? 23 minus 17 is 6. 6, right? 6. Then 17 plus 6 is 10, 23. 17 minus 6 is 11. This is an interval, right? Right. So the question is, okay, in this case, you knew that the actual average was 23. Your actual age was 23, right? Yeah. Uh, okay, we do the first thing I wanna tell you guys or show you is the importance of interval, right? Then from there, now you're gonna be interested in studying the interval, right? So all this is based on understanding why do we need intervals on the first place, right? So what I'm saying, I asked this lady her age. Her age was 23, right? But let's say you don't know her age, right? So if you don't know her age, so obviously you'll guess it. So you've got two papers, right? Two journalists writing a story about her. You've got one paper saying that picture, a nice picture, right? One paper, nice picture of you, and this is a business lady, and her age is 17, right? And we've got another paper, another same picture, from the same picture of her, right? From this picture, and you've got the same line. This is a business. Why not this one? Eh? Yeah, this one. Now, let's say you wanted to buy, you're reading an article about her, and you're going to maybe her birthday. You want to buy her a present, right? So if you're going to her birthday, you know that her age is 17. Probably you'll buy her a baby doll. 17. 17. 700. So, but I mean, you guys understand what I'm trying to show here. So, you might buy something within this age, right? This age group, maybe a crop top, right? But with this one, you've got more options because you're being told that the age is between 17, 18, and 19, right? So even if this one is wrong, but you've got more options here than this one, right? Okay. So this is why it's important to know the interval and just a single statistic, right? Okay. Then we move from that. Then the question I asked was, how sure are you that from this interval we've got the correct age of her? Right. I then came to the fact that I then moved and came to the fact that in everyday life, you've got what is known as the population. From the population, you've got the sample. From the population, you've got things that are called parameters. So everything that is being said based on the population is referred as a parameter, or anything calculated based on the population is referred as a parameter, right? And these parameters are usually unknown. What can you do is to take the sample from the same population and deduce your statistic, right? These statistics are estimates of these parameters, these unknown parameters, right? Right. Okay. So can you see now? I then told you guys that can you see now that obviously there's gonna be an error here. You've got something that is unknown, right? But you've got from the population where you find your parameters, you get your sample, and from the sample you calculate your statistic. Obviously, there's gonna be an error here. Now, how sure are you that from what you've calculated based on the sample, it is close to the parameter? Then you've got your standard error, right? The smaller the error, take this down. So the smaller, so these are nodes. The smaller the standard error, the close you are from the actual parameter, right? The smaller the standard error, the close you are from the actual parameter, which is her age in this case, right? Okay. So do you understand why do we study intervals? Intervals got more information than a single statistic. So it's important to know interval. Then to furthermore your knowledge based on interval is the fact that how sure are you that the actual parameter is within your interval, right? Because at the end of the day, you want the actual parameter, the actual age of her, right? In this case. So how can you answer that? You show that this interval will contain a age if the standard error is small or less, right? The smaller the standard error, the closer you are to the actual parameter, right? So what does that mean? It means that for every statistic that you calculate or you guess, include your error, right? So what is this? This is the statistic. right? It's X bar. This is sample mean, right? From this sample mean that you've calculated, add and subtract your error, all right? So we took an example of someone saying that your age is 17. This is the interval we're getting, right? Right. We found it this interval. Let's take someone else. Let's take someone else. Let's take you. Let's take this one, right? So 24 plus or minus. What is the error between 23 and 24? Is 1, right? So 1. So what is the interval then? It's 23, 20, 25, right? Which is nice. But let's say we don't know your age. What is our error then? Right? That's when these guys come into play. X bar plus or minus. Right? They come into play because number one, you don't know the actual parameter. In this case, you knew the actual parameter is what's 23, right? Which was okay because you added and minus the actual age from what you guess and stuff, right? But let's say you don't know the actual parameter, of which that's always the case. These parameters are always unknown, right? Okay, so add this guy. He has this one minus all this. PQ, no pattern man. Yeah, lead. Then we've got another one which is N minus 1. Let's put it divided by like this. N minus 1 alpha, comma. Guys, help me out. Is it like this? Yeah? Right? Can you see what is this? Is this the parameter or the statistic? A statistic, right? What is this? It's a statistic. Can you guys see that from this you get an interval, right? So all these two, all these three, I mean, these are confidence intervals, right? Now, what is your error if your parameter is unknown? This is error. Do you remember this is standard error? This is referred as the standard error or the standard deviation. So you say, right? The standard error and the standard deviation is one and the same thing. Okay? This is also the standard error but based on the proportions, right? So this is also the standard error or the standard deviation. Then I ask you a question: how sure are you, or what are the chances that your actual parameter is within your interval? Right? How sure are you that her age is within these intervals we've been doing? How sure are you? Then the answer to that is, I mean, obviously, how sure are you? What are the chances that her age is within this interval we just made? We talk of probability, right? So how sure are you? You are 1 minus alpha sure, right? How sure are you that within the interval you have, within this interval, the actual parameters are within these intervals you're making here? You are 1 minus alpha. That's why we've got this part, right? Right? Therefore, you say you 90%. Remember, percentage is the probability. I'm 90% sure that within this interval, the actual parameter is here. Right? Okay, we'll make some examples just now. Your formula sheet. Guys, I've sent it a formula sheet from our WhatsApp group. Let's kindly look at that. Okay. Ngasola ne? But before we go that, let's make some sense of things. Your test is in 19 days. I mean, your exam is in 19 days. You're writing your exam on the 26th of October, which is this month, right? Right? So, how many groups do you have? 3 groups, right? Group 1, group 2, group 3, right? So, how many chapters? So, within this 90 days, this is 2 weeks and 5 days, right? I can only see each group 3 times a week, right? So if I see you 3 times a week, I can only see you 9 times before your exam, right? Right? So how many chapters do we have? We've got chapter 1, chapter 2, chapter 3, chapter 4, chapter 5, chapter 6, chapter 7, chapter 8, then chapter 10, right? So we've got 9 chapters. Okay? So we've got 9 chapters, right? But if you in a private sessions, chapter 8 and 7, you treat them the same. So that's one chapter. Chapter 6 and 5, we treat them the same. So how many chapters do we have? It's just 5 chapters, right? So out of this 9, we've got 5 chapters. Okay. So 7. So 1, 2, 3, 4, 5, 6. 4, 5, and 6. No, for chapter 1, 2, 3, 4, 5, and 6, 7 and 8, 10. Okay. For 7 chapters. Yes, we've got 7 chapters, right? When are you ending with your lecture? Next week, Wednesday. Wednesday. Right? So this is what I'm bringing on the table. From next week, Wednesday, right? I'm gonna see 2 groups in one day to increase this number, right? So I'm gonna see one group in the morning, then see another group in the evening, right? That will increase this number. But me doing so also needs you to work with me, right? You need to consult me. Like every time we do a session and there are things you don't understand, exercise that I give you and you don't understand them, you need to come to me, right? Because it's gonna be pointless to pay your money and stuff, but you fail at the end of the day, right? So you need to consult me. Number 2, you need to prioritize. I know that you guys are being squashed with exam maybe in the same week, right? But this needs to teach you the fact that you need to prioritize. You need to see what's important than the other. Which exam can you tackle first than the other, right? The same level of the sub exam and the exam is the same. The standard of setting is the same. It's To say the stuff is more difficult than the exam, that was before you guys came here. But now that's not the case. If you know your stuff very well, the exam and the sub-exam is the same. So you can't strain yourself and study for two exams that are on the same day, right? You need to defer one, and go write the sub, right? But which one do you defer? You only defer the one that you understand clearly, right? So you need to prioritize. Learn to prioritize. When you can't write four exams, don't rush to finish the exams, right? Okay. So that's the tip for me. So if I'm gonna see two groups in one day, we're increasing this number, right? My plan is to maybe see you guys, each group, to see each group 10 times before the exam, or even more, greater than 10, right? Before the exam. But how many times do I want to consult with you every day, right? I want to see groups more than 10 times, but how many times do I want to see you in my office every day? Right? Even now, consultation, even now, right? And you only defer things that you've got the higher DP on, right? Right. Okay. Okay, then let's go back to what we're studying. Bengit, guys. Koshiwe, man, it's Bengit. Oh, formula sheets. Yes, yes. Okay, so let's work. So now, can you see how tight our schedule is? Okay, so you need to work as hard as possible, twice as hard. There's a formula sheet I've sent on our WhatsApp group, right? I want you to look at the formula sheet that is in this form. Right? Okay. Can you see? Can you see this formula sheet? So I don't have it with me here, but it's on our WhatsApp group. Must I resend it? Resend it. Okay. Okay. Let's see if I can get it. Must I resend it? Okay. Wait. Formula forward to the same group. Got it. Huh? Okay. I mean, the formula sheet is the formula sheet, guys. So whether this one, you've never seen this one, but it's still the same thing as what you have. Let me see this one. Okay. There's also this one. Can you see this one? Yeah. Yeah. Which group are you in? WhatsApp, and go find the new group. Please make sure that you sign ordinarily. Okay, but I want you to take note of the formula sheets that I've sent to you guys on our WhatsApp group, right? Okay, there's a formula sheet on that group that is in this form. Can you see it? Can you see it? Okay. Let's call this box 1, call this box 2, this box 3, then this box 4. Right? Under these boxes, there are formulas. Within each box, there are formulas, right? Right? So let's give a key then. We've got number 1, number 2, number 3. We've got number 1, number 2. You've got number 1, number 2, number 3. You've got number 1, number 2. Yeah, right? Within each box, there's formula 1, there's formula 2. There's other boxes got formula 1, 2, and 3. This one, 3, has 3 formulas. This one has 2, right? Okay. Now let's give a key. Let's give a key. Let's give a key, right? All the number 1s are called test statistic, right? All the number 2s are called confident intervals. All the number 3s are called sample size. Right. And guys still with me. For box 1, box 2, 3, 4, right? Within these boxes there are formulas. Let's label these formulas. For number 1, number 2, number 1, number 2, number 3, number 1, number 2, number 3, number 1, number 2. Right? All the number 1s, if a box is a number 1, that number 1 is referred as the test statistic. If a box has a number 2, that number 2 is called confidence interval. Number 3 called sample size. Right? Okay. Okay. And this formula sheet is for chapter 7 and 8. Right? This formula sheet is for chapter 7 and 8. Right? Okay. So, okay. Okay, can we do questions now? Can we? All right. Remember, 7 and 8 is the same, right? So every time if you're going to be asked a question based on chapter 7, you're going to be introduced to chapter 8 first, right? Chapter 8 is based on, I'm still going to teach you chapter 8, but for now, I want you to know that chapter 8 is based on hypothesis testing, right? Hypothesis testing, right? So every time I can even ask you things based on confident interval, you need to understand chapter 8, hypothesis testing. Or the question will be within your hypothesis testing, right? Okay. Remember, in chapter 5 and 6, these test statistics were known as formulas to standardize. But now you're in chapter 7 and 8, these standardized formula are referred as test statistics now, right? So you use these formulas to test your statistic. What is a statistic? Is everything calculated based on the sample, right? Okay, then let's do questions. Umsendelile, WhatsApp, send me because now every paper we're going to be doing will be based on that group. Okay, from that group, from that private group. Can you open up 2016 semester 1 main exam? Remember now, your preparation is based on exams, so you can't be looking at test 1, test 2, but the past papers you do are main exam, right? Okay, but you can do your classroom test, test 1, test 2, up until test 3. I'll send you guys the PDF of tomorrow's test. But after that's done, then I'll send it to you just to go through it. Because I mean, I know that most people failed, but to me, it's better if you fail, but you know where you went wrong, right? If you were given the same paper, you can get 100%. Then just to fail, but you don't know where you did wrong, anyways, right? So yeah, don't fail. Ngabe nisafeyila na? Okay, can I erase here now? Can I? Okay. Okay, so let's do some questions. Let's do questions. 2016. Did you guys find the paper? Okay, let me also look at it. So, okay, let me add you. Um, uh, okay, follow that link. Let me also send just to the paper. Okay, main exam semester 1. It's a nice paper. It's a nice paper, guys. It's relevant. You are found it. Okay. Okay. So if you scroll down to this paper and go to question 35, right? 35 is the beginning of chapter 8 because 35 is based on hypothesis testing, right? How do I see that a question is based on hypothesis testing? I've got your null hypothesis and your alternative. So meaning the analysis of the yes. This is called, for now, I'm still going to teach you chapter 8, right? So this is called null hypothesis. This is called alternative hypothesis. If I see, I mean, hence H, it is denoted as H naught. If you see H, this means hypothesis testing. This is your null hypothesis, your H naught. Your H1 is referred as your alternative hypothesis, right? So every time you see this, you need to understand this is the beginning of chapter 8, right? So I'm giving you guys a tip. Tip 1. So firstly, chapter 7 is within chapter 8, right? This is the first one. Second tip is the chapter 8 begins with hypothesis testing. I mean H naught, H1. Right? So let's take a random paper, any paper from this group. So we say 35 is the beginning of chapter 8. So what does that mean? We're going to be asked confident interval. Which confident interval is chapter 7? We're going to be asked confident interval within this chapter 8. Right? Okay. So let's take another random paper to prove whether this is true. Any paper. Which paper can you take? Any paper you can take. Look at 2014 semester 1 main exam. Okay, let me resend it to you. Where does chapter 8 begins from this paper? Again, guys. Eh? 2014 semester Monday exam. Where does chapter 8 begin? Question? Question? Bible. Refirm. 35. You all on 35. Okay. Who's not on 35? Uba not speak sorry. Question. Talks of null hypothesis and stuff. Right? Okay. So what does this mean? Confident interval, which is chapter 7, is going to be asked from here now going downwards. Because chapter 7 is within chapter 8. Right. Okay. Got that right? Let's go back to 2016 now. Main exam. Now, coach, I'm going to go with you guys. We've got 19 days and stuff. I can only see you this much and stuff. So everything I say, practice before you sleep. If you don't understand what's happening, consult me. Right? Don't, because we won't have another time to revise these things. Right? We also have other chapters to do. Okay. Okay. So let's go to question. We said question 35. Question 35. Let's go down to question 35. Okay. Look at question 37. What are you given there? You're given confident interval, right? So let me give you another tip. Obviously, a confident interval question is based on chapter 7, right? Okay. Can you see that this question is within chapter 8? Okay. Masulala. Okay. So that being said now, every time, so let me give you a tip. Tip 3. Right? Every time from a statement, if you are given a confidence interval, if you are every time from a statement, if you are given a confident interval, right? The correct answer from that statement, the correct answer from that statement will be the answer that will contain the interval given right, and everything from that statement. From that statement. Okay, so now, if you look at this, right? Every time from a statement, if you are given a confident interval, the correct answer from that statement will be the answer that will contain the interval given and everything from that statement, right? Okay, so look at this question. Question 30, 36. Is it 36? Yeah? 37, right? You're given as which one is better to switch off these lines or this one is better? So Nasulala. Okay. I want us to answer this now. Okay? So you're given an interval of 6.26, 9.54, right? Okay, so it's in a statement. From this interval, you're given the correct answer from this, and you're being told about 90% confidence, right? Remember, how sure are you? The question was, how sure are you that within this interval, the actual parameter is within this interval? You're 90% sure. You're 0.9 sure, right? Okay, so the correct answer to this will be the answer that will contain this interval in this form, and also everything that you're given from the statement. Okay, let's look at A. 10% of retired adults have an average of 6.26 to 9.54 jobs throughout their lifetime. A is not true. Why? You don't, in a statement, you're not given 10%, right? So it's containing, this answer is containing something that you're not given in a statement, right? Okay, is this in chapter 7? This question is in chapter 7. Yes, it's in chapter 7 because chapter 7 is based on confident interval, and this is a question based on confident interval. Yes, 7. 2016 semester 1 main exam. So, okay, now let's go to B. 6.26% to 9.54%. Obviously, B is wrong because we given this interval in terms of percentage, and this is not what you given in the statement, right? Remember, what is the tip? Everything. Yeah. Okay. Let's look at C. Let's look at C. Okay, the average number of jobs that retired adults have throughout their lifetime is between 6.26 and 9.94. Is C true? Huh? Maybe. Right, let's go to D. The average for the fact, look, if C, what's good about C is the fact that good average, right? And average is what you're being told in the statement, right? Okay, that's nice. And yeah. I think there's a typo there. They made a typo, right? Let's look at D though. The average retired person has 6.26 to 9.54 jobs throughout their lifetime. Is D correct? D is the average, but there's something wrong about D. If I'm giving you an interval, look, guys, if you've got an interval from this interval, is 6.26 included? No. Right? Is 9.54 included? No. Otherwise, I would have given you this block bracket, right? So the statement needs to indicate the fact that 6.26 is not included. That's the name of an interval. What is included from the interval is the interval, not these numbers we give, right? Okay. So can you see that D is wrong? Because D is saying the average that a take is fine. Retired person has. So it's starting from 6.26, but that's not the case. Right, so D is wrong. E, all adults, E doesn't have average. Right? So the answer is C. There's a typo there. It's supposed to be 9.54. Right? Okay, let's go through this nice question also. 39. What must be 38? Because it's chapter 8. Why 39? It's chapter 7. How do I see that? It's based on confidence interval. Can you see that confident intervals are within chapter 8? Okay. So now you decide to estimate the true proportion. Remember this spider formula, right? And this spider formula, you've got box 1, box 2, got this guy, box 3, you've got box 4, right? This box 1 is for variance or variability. Or variability, right? Box 2 is for proportions. Box 3 is for normal distribution, and average, right? X bar. Box 3 is the same as this one, but it's for t distribution, and you only use t distribution if your n is less than 30, right? So treat these ones as the same, right? Okay, but I'll give you a question for this today. Okay, so now you want to find the confidence interval based on proportions, right? The question is, you decide to estimate the true proportion. Remember, what is the true proportion? Is the parameter. The actual proportion, the true proportion is the parameter. So you want to estimate it. To estimate it, what you're going to use? P hat, right? Remember, P hat. P hat is used to estimate the true proportion, right? Okay, so what does that mean? You will use box 2 to find the confidence interval. So you're counting box 2 in number 2, right? Because number 2, all the number 2s are extended. All the number 2s are confident intervals, right? So I'm going to use box 2 because box 2 is based on proportions. We are counting box 2 in number 2, right? So write that formula. This formula is P hat plus or minus Z1 minus alpha by 2, the square root of P hat 1 minus P hat divided by N. Is it like this? Right? Right. Okay. So now what is your P hat? What is your P hat? Remember, a P hat is a proportion, right? P hat is calculated in this form. P hat is equal to R divided by N, where R is equal to Are we still okay? Are we still okay? Maswala zokuza man. Okay, what don't you understand? You don't understand why are we using that formula? Okay. Do you understand that the question is based on proportions? How do you see that? The question is, let me read it to you. You decide to estimate, right? You decide to estimate, obviously, the thing that you're going to estimate is for example, right? So estimator is a parameter, is a population. Okay, so you decide to estimate the true proportion, right? The only way you can estimate the true proportion is with P hat, right? So that indicates to you this is a question based on proportion. So in that spider formula sheet, where are proportions? Which box? Box 2. Okay, so you stand in box 2. Why are you standing in box 2? Because box 2 is based on proportions. Okay, so let's then move true proportions of houses that are heated by the natural gas by constructing an ideal present confidence interval. The confidence interval that you construct is the question is based on the confidence interval that you can construct is. So if the question is based on confidence interval, you're in box 2. Which formula can you use out of these 3 formulas that you have that will give you the correct answer? Number 2, right? Remember, every number 2 in each box is for confidence interval, right? Yeah. Yeah, in box 2, there's supposed to be 1, 2, and 3. Let me look at the formula sheets again. Okay. Okay, I want to see the formula myself. Do you guys see number 3? Or I can do that. Let's see. Okay. Okay, we're looking at this. We're looking at this. Okay, you've got box. This is box 1, right? So go and I let the box 1, box 2, box 3, box 4, right? Within each box. No, you don't. No, not that box. That is for 2 samples. When this is chapter 9. This is for chapter 9. Go and like 1 sample. You're not doing chapter 9, right? Okay, so I'm in box 2. We are going in box 2, number 2, right? Okay, so I'm choosing to take this formula, guys. I'm choosing to take this formula. Why this formula? Because this is the only formula in box 2 that's what gave me a confident interval, right? This formula requires p heads. What is your p heads? Remember, you find your p heads from the statement, right? Okay. So your p heads in this case, what is your p heads? Try it out. What is your p heads? Is 0, 0.9. I'm listening, guys. Is 0.9, 0.8, or 0.98? Yeah. This is not proportion. This is your confident. You are confident that the true proportion is within this. So this is not a proportion. I want to look at my 2016. Send it to you. 80. 84, 85, 86. Okay. We here. Yeah. Okay. The Department of Labor reported that. So you look at the statement. So you've got a question from question 35 up until question 37. You use this information, right? Okay. The Department of Labor recently reported that the retired adults and this is that one. No, look at question 38. 38. So from 38 and 39 are based, question 38 and 39 are based on the following information. So you've got an energy information administration recently reported that 51.7% of homes in the United States were heated by natural gas. Right? You would like to confirm this by doing a hypothesis test. This is chapter 8, right? Performing a hypothesis test. This is chapter 8. You select a random sample of 200 homes and find that 150 are heated by natural gas. So this is where you find your p heads, your proportion. You've got what you're interested on, right? Out of 200 houses, only 150 were heated by gas. That's your interest. You're only interested to people that are heated by gas, right? So 150, right? What is the answer here? 0.5? 0.5? 75. Yeah? Okay. Now we can have an argument with why PX will be the probability that you give in the first probability which is 0.517. Right? Now to answer that, go back to which question? Go back to question. What a nice question, guys. Okay, go back to. Okay, go back to question 33. Go back to question 33. Now, do you have that argument with why appears right? Why do we need it to calculate it? Okay, let's go back. Remember, we chapter 6, right? Proportions. To find proportions, what did you do? You said P is P heads, right? You said P, open bracket, P heads is greater than, like for this instance, question 23, what can you say? What's the probability that at least the difference of 0.35, right? Right. And so I want to show you guys something. But from here, you need to standardize. To standardize, you use this formula, P n minus P, right? Okay. Over whatsoever. So what is your P in this case? Yeah? 0.3, right? Then your P is this, right? And you see that every time, whatever you give it is referred as P. Yeah? So that can't be P here because this is what I'm giving you. Okay. Whatever you're given, Jalo Bowens are Bowens are question. Right? So what I'm saying, reason for that is because whatever you're given from a statement is always referred as a proportion. So the true proportion is always referred as the true proportion. Right? Whatever you're given from a statement is always referred as the true proportion, not as P head. Right? Okay. So from now on in chapter 7, you will calculate your P head. Later there was a one doing questions. If you think you're just gonna do this one question and you understand it, then you're gonna have a problem. You need to do questions or calculate P heads frequently, right? Okay. I'm gonna give you questions. Okay. So let's answer this. So you've got 0.575, which is this is my P heads, plus or minus z1 minus alpha by 2 over what is your P head? Is 0.575, 1 minus 0.575 divided by what is your n? 200. Okay, 200, right? So then, now you need to calculate this, your z1 minus alpha, right? So every time you're given a percentage, what I want you guys to do, you need to understand that there are two ways you can do this. Remember, I asked you a question, how sure are you that the true proportion is within this interval? What did we say? We said we are 1 minus alpha sure, right? So every percentage you given is 1 minus alpha, right? So that means that 90%, 90 is 98. Is it 98? So it's 98%. That means 1 minus alpha is 98%, right? Okay, then divided by 2. All this divided by 2. Right? So the first thing you need to do, what is your alpha from here? So if 1 minus alpha is 98%, what is alpha? Is 0.02, right? Then from this 1 minus 0.02 divided by 2, this is one way. You get the answer, right? The other way is just use your calculator and say 1 minus 98% percent all divided by 2. This is one way. This is the other way. What are you getting out of this? 0.01. Out of this, what are you getting? 0.99. Right? Remember, your Z alpha by 2 is the same as minus 7. Right? So it is 0.02, right? How sure are you that the true proportion is within this interval? You are 1 minus alpha sure, right? So every percent that you're given, every confidence that you have, it's a 1 minus alpha confidence, right? So you're given 90% in this case. What does that mean? It means that this 90% is 1 minus alpha, 98%, I mean, right? From this, make alpha the subject of the formula. What is your alpha? Minus alpha, 98% minus 1. What is the answer? Obviously, it's a negative answer, which is minus 0.02 minus alpha. Divide by negative, divide by negative. Alpha is equal to 0.02. Right? Okay. Then the above formula it's 1 minus alpha divided by 2. Right? Then you say 1 minus 0.02 divided by 2. You find 0.99, which is nice, right? But the other way you could do this is just to say 1 minus 98% all divided by 2, getting this, right? Right? Then out of this, you go to your selected percentiles. Look for what is the area under this. What is your Z alpha under this? Because this is the area under the curve. This is your alpha. So you go to your selected percentiles. Is negative 2.8326 326, right? This is positive 2326, right? So it depends which one are you comfortable with, right? If you use this one, use this one, you need to understand that every negative answer you get, it needs to be positive. Where do you find that from this? Right? Right? Because Z alpha by 2 is equal to minus Z1 alpha by 2. Right? So if you do like this, if under 0.01 is minus 2.326, you need to treat this negative as a positive. Where do you find that from that? Right? Or else you go using this way, where you understand that 1 minus alpha is equal to the confidence that you're given, then you make alpha the subject of the formula, then you say 1 minus alpha divided by 2, right? I think this is quicker than this, right? Okay. Then we come here. So we've got 0.575 plus or minus 2.326, the square root of 0.575, 1 minus 0.575 all over 200. Use your calculator to find the confidence interval and tell me the correct answer. Yeah. Go to selected percentile. These are all selected percentile. What are you looking for? You're looking for 0.01, right? Ahola is 0.01, 0.01, right? I'm saying you need to treat this number as a positive local tata from that formula that alpha by 2 is equal to minus Z1 minus alpha, right? So this is what you want because of file that we are putting there, right? Then, yeah. Yeah, sorry. Z tables, hence the formula called Z, right? You look at your selected percentile, so like name. Yes, yes. I'm saying because of this, the number negative which is multi-positive. Because why was I not because of that? Right? Okay. We are over. Alright. I don't know the question there. Okay, let's go down. I know chapter 7 though. It's color now. Okay? Okay, look at question 4. Let's look at okay, question 19 I'm also later reason don't be scared, man. Don't be scared. Mama, I saw this when I said the pattern. But don't be scared. Yeah? That's it. That's it. In there. Yeah, you've been told that to find the confident interval. Find the confident interval with 98% confidence, right? So uthatha leyo confidence leyo uthi 1 minus 98 divided by 2, you get this, right? From this, uyobuka kuma-tables. Why wenza le nto le? Because iyafuneka la kule formula. The first thing la ibalulekile, yes, to be able to do this, guys, the first thing ebalulekile is to identify the question whereby this question is. So to solve this question, I need those formulas, right? They here. Then from those formulas, you're asking me to find the confident interval. So I'll use for 2 because this question we're about in for 2 and number 2 because number 2 is based on confident intervals. This is the formula you have. What is your p hat? You need to calculate your p hat, right? It's not that. It's not the probability that you're given. You need to calculate it, right? Okay. So then you've calculated it. It's this. Then from the plus or minus, you require to find this, right? To find this, you need to use the percentage that you've given. You're being told that the confidence interval is 98% sure. Then the confidence interval. What do you do then? You say 1 minus 98% divided by 2. You get this, right? Under this, you go to the selected percentile in the Z value tables. You'll find this value. I'm saying treat this value as positive. Why do you do that? From that, right? Okay. So say I want thatha leyo value uzoyifaka now. So uzoti 0 we calculate 0.575 plus 2.36. So the fact that you said plus, that means that is the upper bound, right? Right? Uphinde uthi 0.575 minus. Because the fact that you said minus, that means that's the lower bound, right? Okay. Look at question 14. Question 14 ukufuna. Eh? 40. So question 40. Let me look at this. Sisesigrande. Maphumla umazi because we've got limited time, so we won't be able to go back. Okay. So then question 4. Now look, the question is asking you what is the minimum sample size, right? If chapter 8 and 7 now, if the question asks you the sample size, you're gonna use O number by the box. Number 3, right? Llama box, you've labeled formulas within each box. You've got number one, number two, number three. Number one, number two, number three. How many box are one number three? Now number three, we are in sample size, right? So we've got two formulas to use to calculate the sample size, right? Okay. So let's look at these things. What is the minimum sample size you should use if you want to estimate within? So this is your error to be within, right? So this is your error to be within 1.5 billion of true average, right? Okay. So ngoba bekhuluma ngo true average, iliphi box ozoyisebenzisa? Box number 3. Because number 3 based on normal distribution no average, right? Number bani box number 3. Number 3. Because ufuna sample size, right? Okay. Zonke lezi zinto guys, you won't see them with just one past paper. So number 3 unjani lapho z1 minus alpha by 2 divided by e, right? Is it like this? Is it like this? 1 minus alpha divided by 2 divided by e times standard deviation all squared, right? Yeah? Is it like this? Yeah? Okay. So I think it should go about. So n is equals to z1 minus alpha by 2 s times s. S is the standard deviation, right? All squared divided by e. Your error is 1.5. Your z1 minus alpha, what you're going to do, you take 1 minus 95% divided by 2. What are you getting? 1 minus 95% all divided by 2. What do you get? You go to your z table. What's under that? Is minus 196. But can you treat it as a positive? Why? Okay. So you're saying 1.9, 1.6, 960. Okay, that's fine. What is the standard deviation? 6.8. Remember, we are going formula. Why the formula in a Farana assignment? The FOS. It's because the standard deviation is a standard deviation based on the sample, not the population. Right? Now look at this statement here. 5 years ago, a study of large businesses was conducted. It was found that the average revenue of businesses and the standard deviation is 6.8, right? You are to follow up the study to see the average has changed. You wish to construct a 95% confidence of the current average business and need to decide how many businesses including your sample, right? What is the minimum sample size you should use if you want to estimate to be within the true average? You use the standard deviation of the revenue has not changed. That's the reason they told you that the standard deviation of the revenue has not changed. It's because the standard deviation that given is for the population, right? So they emphasize the fact that it has not changed because they want to tell you it's not the same standard deviation they're going to use it for the sample. Otherwise, okay, we'll find a question where they use a different way of given two standard deviations. Yes. Yes.
So we formula is standard deviation. US normal
Is S. Yeah. That's as well. No, it is. Who is it? Yeah, that's your S, right? That's the standard deviation based on the sample. Okay, so yeah, then from here, it's easy to get now the answer 6.8 all squared. These are the only things as a chapter 7. See that in both would say find the confidence interval in both sample size. These are the only two things, right? We have to read this. Let's go to another paper. Let's go to 2017. Here is the 2017 paper. Let's go to the 2017 paper. Is it there? It is there, right? What will be question from chapter 8? Work with me. Oh, no. Yes. Yeah, yeah. Right. Yeah. Bukan guys, man. 2017. Kalau balik, it is. How do you see? That's the beginning of hypothesis system. Okay, you go to the so utazidi kama alisema Nabuzi chapter 7. Because chapter 7 is within which side. Okay, so can you guys do question 40 then? Please, go with it. I'm trying go. I'm trying go. Yeah. Yeah, that's what I'm saying. They're saying replacing by S because this is not real. If you use this, you're saying this is for the population, but if you use S, it means this is a standard deviation for the sample. Yeah, because there's okay, there's in otherwise izinto zabe population usukungenazo. Otherwise wenzela nama tests and stuff ikwazi ukuthi population yozakala. Okay, then short. Anenze nibone nofethu, nani nibone nenze njani. Shine nibone. Okay, so let me give you tips. Let me give you tips. So there's a question, man. 140. The lecture constructs a 98% confidence interval for the variance of scores. What is the upper limit? Ukuluma variance, right? You want the confidence interval for the variance. Which box can we use? It's box number 1. Why box number 1? Because box number 1 is based on whereabouts in box number 1. Number 2. Because number 2 is for confidence interval. But now within this confidence interval, you only want the upper limit. So you're only going to use the second part of this interval only. I mean, guys, never you learn. Oh, I mean, I quote a big exam. Hey, you better call your mama's eyes to get that. Currently, only to box 1 over no variance. And the box 1 is no variance. Right. Then what's it about the confidence interval? Number 2. Or number 2, grammar box, but then confidence interval. But you start at the side, it is not a band, who substitute kanjani kule formula. Kodwa ukuthi uvunile uzosebenzisa iphi formula and stuff. You know that. So now the formula ile ekwazi lo number 3. Athi ngo No, that's these are degrees of freedom. That's not a formula. That's number two. There are only two formulas there. Kwani formula ngiyifunayo, formula shise ngiyifunayo yazi. Kanjani ngiyanayo. But I'll send it to the group. Okay, now we pass. Let's just substitute say, right? This is the part. This is for the upper limit, right? This is for the upper limit, right? This is for the upper limit, right? So what is your n? It's 16, right? So 16 minus 1 is 15. What is your s? What is your s? Remember, this is the standard deviation based on the sample. So what is your s? Is 5.6. Let me look at it. So a lecturer who has been teaching the same course for many years assesses students a lecture by giving them a quiz, and forever the score being recorded for his students' average was right? This year she believes that the variability of the performance is lower than the previous. She randomly selects 16 students from a year and found the mean is this and standard deviation is this, right? Why are you not using 5? It's for the population, right? But here it's S. So this is the standard deviation based on the sample. So that's why we use 5.6 over your chi. This is chi. This is called chi squared. So you want to use now your chi tables. These are called degrees of freedom, right? So your degrees of freedom is n minus 1. So it's also 15, right? Then you've got your alpha by 2, right? Now, what percentage are you given here? 90. 90. So what is your alpha? You know that 1 minus alpha is equal to 90%. What is your alpha? 0.1. 10%. Right? Right. So from this now, you need to divide by 2. That is 0. 0.005. Like this. Then you go to your which tables? Chi. Go to chi. Let me teach you chi. Nyawaza makai. Nyawaza makai. Makai. Yabo like the name ama F. Ama F no more because ama F distribution is for chapter 9. It's for 2 samples. Okay, so put it chi, those people are chi table. Right? Which are called a KSX. Alright. So then what do we do then? Then you go to your 15, right? So from this side, the whole 15. Then from 15, I'm going to answer the value 0.05. By answer to 7.26. Yes. Right? Let's cover this morning. You take this side now, right? Yabo? Same thing. But man, they say 1 minus alpha by 2. Right? Okay. And question 43. Look at question 43. Yeah. Yeah. Then, the 43, eh? Suppose, sure. Oh, okay. Sure. I've called. So, yeah, because we call them the formula sheets, guys. I'm so bold now. I won't explain. So, yeah, then, yeah. Okay. So, let's look at 43. 43, suppose your friend, blah, 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 blah. What is the sample size? Which box are you going to use? That's the first question. Which box are you going to use? Eh? Proportion, so you'll use box 2. Because it's only box 2 or the number proportion. I guess which number are you going to use in box number 3, right? I go, my face, so I understand. So go. N is equal to N. So box 3 and N is equal to what? Yeah? PQ. P is PQ. Not PH. Q versus brackets. Bunny? All over E. Yeah, finally is the square. All squared. All squared. Okay. Finally is the square. Anything. Yeah? I don't know. I mean, angazi formula sheets for guys. Like this. Okay. Then yabo bakhuluma ngo-true proportion. Yes. So your P, what is your P? And it's about when I don't P yet. So to use the first proportion that I've given you. What is the P that I've given you? 0.05, right? You use that. Obviously, Q is 1 minus P. Yeah. No, P is for the population, Q is also for the population. Yeah. I wonder about that. Yeah, again, the one new P. Yeah, we are take P as 0.5, which is half. The highest value of P can be 0.5. Okay. Okay, guys. That's my. Okay, move on to question 45. The question 45 is made there. Now, one question 45. Question 45 is given an interval. From this interval, the correct answer will be the answer that contains the interval and everything. Yeah. Every time, guys. Yeah, so that's a lot. Yeah, you told it. Not 2.3 question, the previous question you just did. This one. Did you guys find the answer? Really? What? 109. What is it now? Yeah, why is it 0.5? You're not going to say that. Every time, so let me see you. Every time you bring us to find a question, you bring us to find a sample size, and you're gonna use the formula here. You always take P as 1/2, right? So that means this is 1/4, then everything else is the same, right? This is every time. Every time you want to find a sample size and you use the formula. Every time, you go 1/4. Right? Okay. P and Q, so 1/2 times 1/2 is 1/4. Because Q is equal to 1 minus P. So Q is 1/2. P is 1/2. 1/2 times 1/2 is 1/4. Okay. Yeah, guys, this is confident interval. Do exercise on chapter 7. On our WhatsApp group, there's book 2 tutorials, right? From that book 2, do chapter 7 exercises. Do the numbers that are indicated there, right? If there's a question you don't understand, there's a moving consultation, right? Or you send me a WhatsApp telling me to explain it. Right? Before sending chapter 8, make sure what you understand the method. Bese wenza 2014 wenza ama-confident intervals nakhona lokhu esikwenzile. Ama-confident intervals azala ama-questions awu-3. Zidla ngibuza i-confident interval, mina awu-2, confident interval or sample size. So bangathiwa it's either kumele wazi i-confident interval or wazi sample size. Just these two things, that's just the same. Nice. Okay, for the question and the thing and send it look at it whereby to find the confident interval they use box 4, right? Obviously you use box 4 if your n is less than 30, right? But you're still estimating your x bar sample mean. I'll see you guys tomorrow on the SI. Yeah. Yes, I don't see that. Make sure the 2014 I had like a book on my phone for my phone. 2014, 2017, 2016. 2014 with the confident interval. I identify what is now so confident interval and yeah. You go look for a question and confident interval. Uyayenza 2014, 2015, 2016, 2017. If I register, make sure that you sign. You consult. Who are you consult uzapina uyanoka kuyeza ule uzokoka kwela woza uzokubuza right. It's not fun. Yeah, it's a fun. Yeah. Posto ya para no post 3. The only difference which is ya para los post 3. Because it's two post 4 if your end is this. So yeah. Umpalele kama lako la student name the signature. Oh, umpalele man. Put a star on your name next to it. Nonkokheli kama lasesontweni. Hayi. Awucabanga ufail unegama elimnandi kanje. Nonkokheli failed. Hayibo.